Welcome to Eureka Math. I'm Mr. Shankel. I'm helping you today with Module 1, Lesson 11. Let's get started. Okay, the exercise 1 gives us the mass of a proton, and we have to write it in scientific notation. So first thing I notice is my decimal is here, and I need it to be here. So I've got to move my decimal quite a ways. But my answer is going to be 1.672622 times 10 to the something. And let's see, I've got to move 3, 6, 9, 12, 15, 18, 21, 24, 27 spots. So my number is a 27. Now I have to decide whether it's positive or negative. And I had a super small number, something way less than 1, and I'm changing it to a 1. So my number is getting bigger. That means my exponent has to adjust. So this exponent is a negative. And there is scientific notation for that giant number. Exercise 2. The mass of an electron is given as that number, and again, same thing. I'm going to move this decimal from there to there, between the 9 and the 1. So I'm going to get 9.109382291 times 10 to the 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and then one more, 31, so that's to the negative 31. There is scientific notation for the electron. Write the ratio that compares the mass of a proton to the mass of an electron. All right, so let me grab that. All right, so there is the mass of a proton, and we're going to compare that to the mass of an electron, and there's the mass of the electron. All right, so there's our ratio. Mass of the proton compared to the mass of an electron. That's exercise 3. Exercise 4, compute how many times heavier a proton is than an electron. So we've got to find the value of the ratio. So we're going to take that ratio from our exercise 3 and put it in this slide. So let me do that right now. Okay, so then we can just divide 1.672622 divided by 9.109382291 gives us the answer, which is 0.1836 so I'm gonna round it there. We'll be pretty close. And then times 10 to the, well, what power? Well, this is division, so we're subtracting the exponents. So let's do this. Negative 27 minus a negative 31. And so this becomes positive. So it's a negative 27 and a positive 31. That's a positive 4. So it's 10 to the 4th. And then we can rewrite this as scientific notation by moving one place to the right, and that would be 1.836 times 10. Well, I had a small number. I'm making it bigger, so my exponent has to go smaller. It has to be a little bit smaller. So 1.836 times 10 to the 3rd, which if we wanted to know what that was to find out how many times heavier the proton is, we would move 3 decimal places, and that would be 1,836 times bigger. 1,836 times bigger the proton is than the electron. All right, that's exercise 4. In example 2, the U.S. national debt as of March 23rd, 2013, rounded to the nearest dollar, is that number. According to the 2012 U.S. Census, there are about 313 million U.S. citizens. What is each citizen's approximate share of the debt? So we're going to take the U.S. national debt, which is here. I'm going to write that in scientific notation. And I'm going to approximate it so we don't have such a long number here, but it will be 1.68 if I round up, 1.68 times 10 to the something power. Well, let's see, I've got 3, 6, 9, 12, 13 in order to get right there. So that's 10 to the 13th power. That's the national debt, and then I'm going to divide that by the number of citizens, and the number of citizens is going to be 3.14 times, if I round it, 1 times 10 to the, and let's see, I've got 3, 6, 8. So that's 10 to the 8th, and then I just divide. So when I divide, I get 0.535 times 10 to the, well, we're dividing, so we subtract the exponents. 13 minus 8 is 5. So there it is. And then if we wanted scientific notation, I've got to move here, so that becomes 5.35 times 10 to the, well, I made it bigger, so my exponent's going to have to go smaller, times 10 to the 4th. And to put this in standard notation, then I would move 4 decimal places, 1, 2, 3, 4, and that would be 53500. So about $53,500 per person is our share of the national debt back in 2013. More now, for sure more. All right, let's get back to the exercises. Exercise 5. The geographic area of California is 163,696 square miles, and the geographic area of the U.S. is 3,794,101 square miles. Let's round off these figures to the following scientific notations. In terms of area, roughly estimate how many Californias would make up one U.S., and then compute the answer to the nearest ones. So we're going to take the area of the United States and divide it by the area of California. So the area of the United States is 3.794 times 10 to the 6th. And we're going to divide that by the area of California, 1.637 times 10 to the 5th. And then we just perform our division. So 3.794 divided by 1.637 gives us 2.32, if I round up, times 10 to the, well, 6 minus 5 is 1, so 10 to the first power. Okay, and then that if I want this into the nearest ones, then I'm going to move my decimal one place to account for my exponent, and I get about 23. 23.2, and if I round to the nearest ones place, it's going to be 23. So about 23 Californias will make up the United States. Very good. Okay, exercise 6. The average distance from Earth to the Moon is about 3.84 times 10 to the 5th kilometers, and the distance from Earth to Mars is approximately 9.24 times 10 to the 7th kilometers in year 2014. On this simplistic level, how much farther is traveling from Earth to Mars than Earth to the Moon? Well, this is a subtraction problem, so the farthest is from Earth to Mars, so 9.24 times 10 to the 7th, and we're going to subtract we're going to subtract the distance from the Earth to the Moon, 3.84 times 10 to the 5th. And in order to subtract, remember my exponents need to be the same, my powers need to be the same, so I'm going to change this. I'm going to change it from 3.84. I'm going to make my exponent bigger, so my number is going to be smaller by 2. So let's rewrite this. 9.24 times 10 to the 7th, and we're going to subtract, and we're going to get a decimal here and a 0, so this is going to be 0.0384 times 10 to the 7th. And now we can subtract, and when we subtract that, 9.24 minus 0.0384, we get a 9.20, if I approximate it and round it, times 10 to the 7th. So it's that much farther from the Moon to Mars. All right, that is lesson 11. Hope that helps. See you again next time.